Going to start Unit 5. The title of Unit 5 is Pressure Measurement. The quantity of pressure is given by this simple relation, force per unit area. If suppose we consider a case of if pressurized fluid, the piston mechanism is available over here, then in this case, if suppose we apply pressure in this direction, the fluid pressure gets changed, it may increase or decrease based upon the pressure force increase or decrease. So if the force applied on a particular area is static, then the corresponding pressure is also static. That type of pressure is called as static pressure. If the applied force on a specified area is fluctuating or dynamic, then the corresponding pressure is also called as dynamic pressure. So basically in Unit 5 we try to cover pressure measurement, right? So the pressure measurement will be discussed based upon the range of pressure, right? The pressure measurement is discussed based upon the range of pressure. If the range of pressure is medium, so we have means available which cover medium pressure measurement. If the range of pressure is low, then we have means available which cover low pressure measurement. If the pressure is high, then we have means available to measure high pressure. So in this particular unit, we try to cover or classify our content into three parts. One part discuss medium pressure measurement, another part discuss low pressure measurement, and last part discuss high pressure measurement. Is it clear to everybody?
Yes, sir.
Yeah. In today's class, what I will do is I will restrict myself to introduction followed by the discussion on medium pressure measurement. So we will cover this in today's class, partially, not fully. Okay, I'm coming to a simple presentation. Okay, this I already covered. I told you the definition of pressure is force per unit area, okay, or the force exerted on a particular area. If you consider the case of a container, the force applied on a particular area of fluid is called as pressure of that particular fluid. So if suppose we consider the unit as newtons and area as meter square, then this will be in SI unit, Newton per meter square. So as I told you, pressures are basically classified into two types: static pressure, dynamic pressure. Static pressure means if force is static, pressure is static. Dynamic pressure means if force is dynamic, pressure is dynamic. So this I already covered. Okay, let us see something on the units of pressure. So these are the few units of pressure. Basically, the pressure is measured in terms of the atmospheric pressure. So 1 atm is nothing but 1 atmospheric pressure. Its value in other form, that is PSI. PSI stand for pounds per square inch, is 14.7. If we try to measure this in kilopascal, it will be 101.3. If we try to measure in the height of the mercury level, then it is 760 millimeter of mercury. If you try to measure on water, then it is of 10.3 meters of water. If you try to measure in bar, it is 1013 millibar. Okay, the other unit is 1 pascal is equal to 1 Newton per meter square and 1 bar is equal to 100 pascals. Okay, fundamental information regarding the pressure. Usually, pressure is measured as absolute pressure. Pressure is measured as absolute pressure. The value of absolute pressure is measured, here formula is available, in terms of a reference pressure called as atmospheric pressure, which remain constant. If suppose pressure is above atmospheric pressure, the gauge pressure is above atmospheric pressure, then absolute pressure is simply the sum of atmospheric pressure plus the value of pressure coming from the gauge. If suppose pressure is below the atmospheric pressure, then the value of absolute pressure will be atmospheric pressure minus the value which we are getting from the gauge. Hope it is clear to everybody.
Yes, sir.
Yeah. Okay. This I already told you. The pressure measurement is classified based upon the range of pressure under measurement. If it is in low pressure, the range covered is in micrometers or tar. If it is in medium range, then it covers from 10 to 10 to the power 8 pascals. And any pressure above this is called as high pressure. Okay. As I already told you, in today's class, I am going to cover information regarding medium pressure. So, medium pressure. This tree explains the different means available to measure medium pressure. So, medium pressure can be measured by classifying the pressure into static pressure and dynamic pressure. If suppose the pressure is static, if the suppose the pressure is static, then we use manometer mostly, okay, to measure that class of medium pressure. There are different types of manometer. We restrict ourselves to YouTube manometer in our case. Okay, inclined type manometer available, well type manometer available, okay, conventional manometer available, but we cover U shape type manometer. Okay, what is important in the from this tree? The important thing is we need to understand how medium pressure measurement is classified. It is classified based upon whether the force is static or not. If the force is static or the pressure is static, we use these are the methods. If the force or the pressure is dynamic, then we use these means. Okay, so for measurement of dynamic pressure, we use some element called as force summing element or force summing devices. This is also called as elastic element. You see this name in our course. In our course, it is mentioned that the methods available with the help of which we can measure medium pressure is using elastic element. Elastic element is also called as force summing devices, okay, which is used to measure dynamic medium pressure. Okay, so first elastic element is diaphragm, second one bellows, and third one burden tube. There are three types of diaphragm. One is flat, something like this, a big rod or if platform kind of thing is available on which the force is applied. On the other side, we observe displacement. In case of corrugated shape, the shape of diaphragm is like sinusoidal signal. Here also, on one direction, force is applied, on another direction, displacement is created. Capsule. Capsule means the shape of diaphragm is of capsule shape, like this, something like this. On one direction, force is applied, on another direction, displacement is created. Okay, billows. Billows is like balloon, right? Whose one side is open, another side is closed. On the open side, force is applied. On the closed side, the pressure is or the displacement is created. Burden tube, it's like a tube. Okay, our bike tube or the vehicle tube, cycle tube, whatever it may be. There are three types of Bourdon tubes. One is C shape, helical shape, spherical shape. So this spherical shape or C shape, they are circular shape, and this helical type is non-circular. Whatever it may be, here also the same thing happen. On one side force is applied or pressure is applied, on the other side displacement is created. Is it clear to everybody?
Yes, sir.
Yes, sir.
Yeah. Okay, let us consider the static medium pressure measurement. As I already told you, I am going to cover only U2 manometer. Okay, this is U2 manometer. The construction is very simple. It consisting of a U-shaped tube having a scale connected. So one of the pressure is kept constant, usually atmospheric pressure, and the other side of tube is exposed to the applied pressure. So the moment the applied pressure is applied, then what happens is the height gets increases or decreases based upon which force is dominating. If atmospheric pressure is dominating, then the height is like this. If the applied pressure is dominating, the height will be down. So this U-tube manometer consisting of U-shaped tube having manometric fluid in which uh, water or mercury can be used as the manometric fluid. The advantage of this is the mass density of this fluid can be obtained easily. The density of water or the density of mercury is known to us. So using this simple formula, P or P1 minus P2 is equal to rho GH. Rho is nothing but mass density of the fluid. If it is water or if it is mercury, we know that thing. And G is nothing but acceleration due to gravity, and height is coming out. Okay, coming out because of the change in pressure. So if we measure the value of height, we can calibrate these in terms of pressure. So P1 minus P2 is simply equal to rho GH. Rho is known, G is known, H is calculated. So it means that P2 is atmospheric pressure, P2 is known, rho is known, G is known, H is coming. So P1 can be calculated. P1 is equal to P2 plus rho GH. So just now I told you the absolute pressure can be calculated as P atmospheric pressure
Atmospheric pressure plus P.
plus, here the gauge value is rho G H. This is nothing but gauge pressure. Is it clear? Yes, no. Rho G
Yes,
into
sir.
H is giving by the gauge. Okay. So absolute pressure will become atmospheric pressure plus the gauge pressure, which is nothing but rho GH. Hope it is clear to everybody.
Yes, sir.
Yeah. Now I am coming to the other part of medium pressure measurement. That is nothing but dynamic pressure. I told you the dynamic pressure can be calculated, sorry, can be done. The dynamic pressure measurement can be done with the help of elastic element or four summing devices. It's also called as elastic element. Usually, the elastic element is used as the primary transducer. I will introduce this term in next class in detail. In case of medium pressure measurement, if you are using four summing devices, then this four summing devices is used as primary transducer, whose job is to convert force or pressure into displacement. Right? The secondary device or the secondary transducer can convert this displacement into electrical signal. So the concept of primary transducer and secondary transducer can be made clear if we use elastic element as one of the component to measure the applied pressure. Okay. In this case, the four summing devices or elastic element is used as primary transducer. You see, the four summing devices are those which convert the applied pressure into displacement, right? Acting as primary transducer, while the generated displacement can be measured with the help of secondary transducer. Hope it is clear to everybody. Yes, no?
Yes, sir.
Yeah. What is the job of secondary transducer? To convert displacement into electrical signal. Okay, we have already seen that the commonly used force summing devices can be diaphragm, bellows, and Bourdon tube. Let us consider diaphragm. As I already told you, there are three types of diaphragm: flat shape, corrugated shape, capsule shape. Flat shape is simply like a straight line on which at one side pressure is applied or force is applied, and on the other side displacement is created. Corrugated shape is like sinusoidal signal, already told you, right? Here also on one side pressure is applied, on the other side displacement is created. Capsule shape is like capsule shape on which one side pressure is applied, on the other side displacement created. Hope it is clear to everybody.
Yes, sir.
Yeah. This is a simple setup of gauge which is made with diaphragm. So detail about this I will cover in next class, because the next class is actually covering in detail about this primary secondary transducer kind of setup, that is called as pressure measurement using transduction method. So just for making the thing clear, I have included this picture. Otherwise, you can skip this thing. There is one chamber at which the pressure under measurement is applied. There is a setup of spring on the other side. So displacement is created because of this applied pressure. So here the reverse force is created. If this force and this force become equal or at equilibrium, the pointer will be pointing to one particular point, and that is indication of the applied pressure. Hope it is clear to everybody. Detail about this I will cover. Don't worry, it is just for making the thing clear. Okay, this diaphragm can be of flat shape, this diaphragm can be of corrugated shape, this diaphragm can be of capsule shape. Okay, bellows is like balloon having one end open, another end closed. So a bellow gauge contain an elastic element that is convoluted. Convoluted means convolution. Series of multiplication and addition is called as convolution. So this type of elastic element is actually convoluted. Okay, in order to amplify the in order to amplify the generated displacement. So the bellows are convoluted and expand and contract axially with the change in applied pressure. So the displacement which is created in this axle can be increases or decreases based upon the applied pressure. Detail about this I will cover in next class. Okay. Next elastic element is nothing but Bourdon tube. I told you Bourdon tube is like our tube of tire. Okay. Which expands or contract based upon the pressure applied. So it is having one open end and one closed end. At open end, the pressure is applied, and you see the Bourdon tube is in bend form when pressure is applied and look like a circular arc. Circular arc. The angle of arc varies with the applied pressure, and accordingly indicated pressure will be changing. So these are the different types of Bourdon tubes. This is C shape, which look like C, and this is helical shape, and this is spherical shape. Okay. That's all from today's class. Any doubt?
No, sir.